Welcome to lecture series 8051 microcontroller. In today's session we will discuss about serial data communication. Normally we are communicating between the two tools, two devices or between the two users, right? That communication, how we are communicating. The signal is transmitted from one end to another end. Whether the data will be communicated either in serial communication or parallel communication. In parallel communication means number of wires are used, okay. So, parallelly the bits are transmitted. By giving a single clock pulse, the number of bits, in case of 8051, 8 bits we have. So, the 8 bits are transmitted by the single clock pulse, that is the parallel communication, okay. In case of serial communication, the 8 bits are transmitted serially, that is bit by bit transmission are occurred. Mostly it started from the LSB. LSB is least significant bit. So, first it will transmit D0, then D1, D2, D3 up to D7. So, this way only it will transmit. Every bit will be transmitted with respect to the clock pulses. So, 8 clock pulses required to transmit the 8 bit in case of serial mode. In case of parallel communication, only a single pulse is enough to transmit the 8 bits. But according to that, the parallel communication give the more speed and the cost is increased. In serial communication, it is a bit by bit transmission which having less cost. Okay. Then in case of serial communication, what are the types of communications? Okay. Because the communication is performed based on the clock signal. So, according to the clock signal, the communication, serial communication again divided as two categories. One is synchronous communication, another one is asynchronous communication. In case of synchronous communication, what it represents, the transmitter and receiver both are using the same clock frequency. If both of them having the same clock frequency, then they started to transmit the data or for the transmission, then it will be called it as a synchronous. In this synchronous communication, it will support for the block oriented communication or transmission. Block oriented means byte wise we can transmit or group of data we can transmit it. Okay, that is why it is it's a synchronous communication which will support the block oriented communication. The another one is asynchronous communication. In case of asynchronous, the transmitter and receiver both of them may use the different clock frequencies. It will support different clock frequencies, okay, either 64 kilobytes or 16 kilobytes. The different supporting frequencies or clock frequencies also available. Based on that, the users can use it. Okay, if the both transmitter and receiver were using the different clock frequencies, then it is called as asynchronous communication. In this asynchronous communication, here it is supporting the character oriented. Character oriented communication means only characters will be transmitted. The characters are considered as a frame that will be transmitted. Suppose you want to transmit the letter good means first the D will be, because we started with the LSB, first D, then O, O, G. That way we are transmitting. Okay. So, this is the basic thing. What is parallel communication, what is serial communication according to the number of lines, either byte wise transmission or bit wise transmission. Okay. Then according to the clock, whether both transmitter and receiver are synchronized with the same clock frequency, then it is called as a synchronous communication. Otherwise, it is called as a asynchronous communication. Now, we will discuss about the data transmission. In data transmission, now we are started, right. In this, how the data is transmitted between the users based on the mode. The first one is simplex. Simplex means only the transmitter can transmit the data. Receiver only can receive, they couldn't reply. Okay. It is like text messages. In olden days they were received by using the pager. The pager is used only for receiving the data. That is the best example for simplex. It is a one-way communication. The another one is half duplex mode. Simplex means one-way communication, duplex means both-way communication. In both-way communication, again it is in duplex we have a half duplex and full duplex. In half duplex means the transmitter will transmit the data, the receiver can receive it. Only one person can receive at the time, right. At the time the receiver cannot transmit the data. In the device having the transmitter and receiver on both end, the user 1 want to communicate the data to the user 2. At the time the user 1 having the supporting of transmitter and receiver in the device. The user 2 also having the transmitter and receiver in their device. Okay. So, now only one part is active at a time. Only the user 1 can transmit or user 1 can receive the informations. Like walkie-talkie, the best example you can consider the walkie-talkie, whether he can send the data or he can receive the data. Simultaneously he cannot do the action. That is the half duplex. In full duplex, they have a separate line for the transmitter and receiver. At the same time, we can transmit the data and also we can receive the data. That is why it is a full duplex. The best example is telephone line, landline. Nowadays the mobile, everything is developed with the full duplex mode. This is a way of data transmission, either in the simplex, half duplex or in the full duplex. The next one, now on the line, how the data are transmitted. Mostly we are transmitting the data, right? Number of bits are transmitted. Based on that, number of bits transmitted per second will be defined as the baud rate. Okay? How the data is transmitted in the serial communication will be defined by the baud rate. The baud rate is number of bits per second, or it also defined as number of signals changes per second. Okay? Either number of signals, either zeros and ones. We are doing the binary communication. In that case, the 0 and 1s are used with the representation of the pulse. Whenever the signals are changes, that will be counted. Based on that, we are defining the rate, that is the baud rate. And while transmitting the data, the number of bits which are the given message, not only we are transmitting the message which will be converted as a frame, we are transmitting the data in the form of frames. The frame is nothing but message along with the start and stop bit. Okay. So, here it is a 8-bit processor. So, 8 bits we are added, 8 bits along with the start and stop bits. So, totally 10 bits. So, this entire structure, entire pattern is called it as a frame. In serial communication, the data transmission is performed based on the frame format with we are defining with the baud rate. Okay. So, in this example, we are transmitting the character A. Character A, its corresponding ASCII value. Okay. So, these are the bits 1, 0, 0, 0, 0, 0, 1, 0. These are the bits, actually 7 bits, dummy bits 8th bit is added because ASCII is a 7-bit representation. This is a start bit. Start bit is always 0, that is always started with low. The stop bit is always high. Okay. This is the information, that is 8-bit information along with the low position of start and high position of the stop bit. So, this is called it as this entire 10 bits is called it as a frame. This frame is specifically for the character A. Okay. Then according to the designer, they can add some space or some mark represents this is the starting of the frame, because we continuously transmitting the data. So, we have to identify this is a frame. Then after identifying the frame, first we have to remove the start bit. Then we have to read the continuous 8 bits because it simply consists number of ones and zeros. Based on the mark representation, the next bit is low, then we consider it as a start bit. Then D0 to D7 is received and stored in the register. Then we are identifying the high value, which is a stop bit. Then it indicates the bits are received and stored in a specified place, and it is ready to receive the next byte. Okay. So, this way we are transmitting, that is why the mark and the space is represented to identify the frame. Now, consider the next example. I ask you to send the data small a, okay, in the serial communication. So, in serial communication, how do you start the character A, or how to form the frame for the character A? So, first you have to identify its corresponding ASCII value, which is 97. Okay. So, 97, its a binary representation value was 0, 1, 1, 0, 0, 0, 0, 1. Okay. It is a 7-bit representation we added with the 0. So, totally we get 8 bits. So, along with that we have to add the start and stop bit. The start bit is always 0, stop bit is always 1. So, totally we get 10 bits. So, this 10 bits is called it as a frame. Now, we have to start the waveform, which is initially the high value, then low, then it goes to high for 2 bits, Okay, I am drawing with respect to the clock pulse. So this is a 1 0, then another 0, then 4 zeros I have to draw it, right. Then it goes to high value for one period, then comes to low, then it is a low. Okay. So this is a start bit, this is stop bit. These are the character for A, ASCII character. The entire 10 bit position, the pulse representation is called it as a frame. Okay. So this is the way we are doing the serial communication between the two users. The device will supporting the different baud rates like 100, 150, 300, okay, up to 1000, 19,200. Okay. So this kind of different baud rates are available. In 8051, these 4 baud rates will consider, and we will write some program according to this baud rate. So how the baud rate is defined? According to the system, it will be varied. Suppose you are taken one of the system, because we are developing the application based on the processor or based on the controller. Each processor and each controller based on the advanced technology, it having the different clock frequencies. We are designing based on the system clock. So we have to know what is its operating frequency, then only we can calculate its corresponding baud rate. So consider this is a crystal oscillator, this is a frequency generated for 8051. So in this frequency, after receiving, it will be divided by 12, because this frequency for one machine cycle. So one machine cycle which consists of the 12 pulses, right, 6 states with 12 pulses. I want to get us for single pulse, that is why it was divided by 12. Then according to that, after divided by 12, I get 921.6 kilohertz. This is the actual frequency. Then based on your mode, serial mode communication, either you can reduce it or increase it. For reducing, we are selecting the value 0. If you are selecting 0, then it again divided by 32 based on the pre-scalar value. Then you will get 28,800 hertz in case of reduced bandwidth baud rate. In case of serial mode equal to 1, then you will get 57,600 hertz. Okay. So this is a baud rate finally we are getting. Suppose I am asking you to generate the baud rate for 9,600 means, then what you have to do, this frequency you are getting, right, that 28,800 divided by 9,600. So what value it comes, that is the required value for your design. So suppose if it comes as 3 means, this is a 3, the decimal value, then you have to load into the specified register, then you can do it. This kind of explanations will be discussed later. So now we will discuss about the serial connector. Serial connector means when two devices want to communicate. In serial communication means via the serial port only you can communicate. So the serial port means separate connector we have, right. In the serial port, in system wise, the mouse is one of the serial port connector. Via the mouse only, via the D type connector we are using, right. Another serial port which is used for the serial communication. Suppose the two devices want to communicate in serial, then we have to connect it via the RS-232 cable. Okay, via that cable only you can perform the serial communication. That RS-232 cable, which is a D type 9-pin connector. Among the 9 pin, I will discuss what are the function of each. So the first pin or signal which have the carrier detector, right. After detecting the particular signal, this will be the carrier detected signal will be identified by using this signal. RxD, second pin is RxD, which is used to receive the data. This is the input signal. Transmitted data is via the third pin, the user can transmit the data receiving. Then only it will give the data terminal ready. The fourth pin is data terminal ready, which indicates when any one of the user want to transmit the data, then first it will activate data terminal ready. Okay. For that, then it will respond it data set ready. When the receiver point or the communication device is ready, equipment is ready, then it will give data set ready. According to that, the remaining will be performed. Then request to send means before sending the data, it will get the permission request to send. Then clear to send. After getting the clear to send only, it will do the transmission. Okay, these two are the handshake signal. Before transmitting the data, it will identify the route clearance. The same way, the data terminal ready and data set ready, both are checking both devices are active or not. Okay. The fifth pin is signal ground. It's a normal ground. Then ring indicator, which will give a blinking of lights which indicate the communication path is okay. Okay. So, based on the indicator, you can identify the signal is received via the receiver node and also we are transmitting the data. So, this is a complete structure of serial communication. In this, we are consider the DTE system, right. In the previous case also, the data terminal ready, data set ready, all are communicated between the data terminal ready and the data communication equipment. The data terminal equipment is nothing but the end user, which might be the mobile phone or computers or routers, any one of the device. Okay. The data communication device equipment is like a modem. It will receive the data from the user, then it will responsible for transmitting to the another communication equipment. It might be performing via the wired media or wireless media. Okay. So, based on that, now the data from the router received, then via the modem it passed to the mobile or any one of the cloud, then it again comes to the modem to the system. So, in that case, how we mainly focusing the communication between these two. Okay. This way is for receiving point, this one for transmitting point. So, now how the communication is performed between the data terminal equipment and the data communication equipment. When the device is ready, it will give the data terminal ready signal. Okay. Because it have the data which to be performed in the serial communication. Now, it activate the data terminal ready. When the communication equipment is ready, then it will give the data set ready. Data set ready means the receiver point also ready. Then both are active. Now, it was asking or requesting to send the data RTS. Once it is ready to receive the data, then it will give clear to send. Okay. So, these two are one of the handshake signal. These are the handshake signal for the device. This is for route. Now, the data will be transmitted via the DXT line. Okay. In case of receiving means, it will be transmitted via the RXT line. Two separate lines are available, one for transmission, another one for the receiving. So, this is a communication between the data terminal equipment and data communication equipment. These are the simple introductions about the serial communication. Now, how the serial communication is performed by the 8051. In 8051, we have two pins which are in the port 3. Okay. In the port 3 is a multifunction port which will support for the timer, interrupt, serial communication. So, for the serial communication, we have two separate pins, one for transmitting the data via the pin TXT, another one is RXT for receiving the data, which is port 3.1 and port 3.2. Okay. Then special function register, which is give the control word format. It is like a control word format which is used to define the peripheral functions with the controller. Okay. So, based on the physical interfacing, now we have to activate the corresponding bit positions which are available in the special function register. So, for that we have three special function registers: serial buffer, it is a temporary storage which is in the format of serial data. Then SCON and PCON. SCON is a serial control which will give the control informations about the serial communication. When the receiver interrupt is occur, then receiver transmitter interrupt, in what mode we are operating, that kind of informations will be, it is a 8-bit format available in that. Then PCON is power control, only one bit is available which is to supporting for the serial communication. Now, how the serial communication is performed in 8051 via the RS-232. This is a RS-232 pin, right. Here we have two signals which are TXT line and RXT line. This is a TXT line, this is RXT line. this TXT line will be given to this transmitter pin of MAX 232. This is a TTL support between the 8051 and RS232 cable or connector you can give. So, this will be connected in the RXT line, which is port 3.2. Here the transmitted signal, which is port 3.1. So, the 8051 is interfaced to the RS232 via the MAX 232. The MAX 232 is supporting device between the 8051, that is voltage compatibility between 8051 and RS232. So, before entering into the discussion of special function registers, now we will discuss how to calculate the baud rate. So, to calculate the baud rate, it will be different for the different system clock. Now, we will consider the 8051 which have the clock of 11.0592 megahertz. Okay. So, this is a megahertz. Now, this is a clock frequency is applied. With respect to this clock frequency, we are consider that frequency for one machine cycle. If one machine cycle means that machine cycle consists of 12 pulses, that is why we are divided by 12 to get a single pulse. For a single pulse. So, in the single pulse only we have to identify, that is why we are divided by 12, we will get 921.6. Then within this I want to identify the baud rate. So, again it was divided by 32, we will get 28,800 hertz. So, this is the frequency which is supporting for the serial communication, which also call it as the UART. UART is Universal Asynchronous Receiver Transmitter. Suppose I am asking you to find the baud rate for 9600, means what you have to do, 28,800 divided by 9600. Okay. So, the value is 3. So, the 3 how we are doing means we are supporting with the help of timer to initialize the values. So, the timer values we are considered as a FF value. Okay. So, FF minus 3 we are giving. FF minus 3, what is the value of that? FDH. So, this value will be loaded in the timer H1. Okay. So, by this way only we are calculating. By any different baud rate, suppose 1200 means it is the 28,800 will be divided by 1200, then you will get the value as 24. The 24 is subtracted from the FF. Then its corresponding hexa equivalent will be loaded in the TH1. Either you can do it with FF or you can subtract with the 256. 256 minus 24, then you convert into the hexa equivalent. Then load this value into the timer 1. Now, we will discuss about the SCON format. SCON format is a serial control or a special function register, which is a 8-bit format. Within that we have the function which indicate the receiver interrupt. When the signal is 1 means it will indicate the receiver interrupt. What it represents, it will rise during the halfway of the stop bit. What it represents, it has received the 8 bits. Now, the SBUF become empty, it is ready to receive the next consequent bytes. Okay. The another bit position which is used for representing the transmitter interrupt, this is used to indicate when the buffer, S buffer is having the full of data. Okay. When it is 1 means it will rise the interrupt from the transmitter. Now, we will discuss about the PCON register. PCON is a power control register, it is one of the special function register which is supporting for the power control and also for the serial communication. So, it is the 8-bit, out of 8-bit only 5 bits are used, right. This is the ideal one. When it is 1 means the system is in ideal. If it is 0 means whenever you are continuously, whenever you are not using your system, it not enter into the ideal mode. In the ideal mode means it was used for the power saving, right. This is a power down. Whenever any abnormalities is occurred, it automatically power down your system if it is 1. Otherwise, it will not do that, then it automatically causes some problems. So, we have to set the corresponding bit positions. These two are the general flags. General flags F0, GF0 and GF1, but it is reserved for future use, or the user can use it for any their own applications. Then 7th bit is the S mode, which is used to activate the serial communication. Whether if it is 0 means the normal baud rate will be used. If it is 1 means the baud rate will be doubled. So, double baud rate can be used by this. So, how can we activate this PCON format means? It is not a bit addressable register. So, whatever the bit positions, in case of bit, what we are doing, set bit of PCON dot 7 you can give it, right, but it is not possible because it is not a bit addressable. So, first you have to move the content into the accumulator comma PCON, the entire format you have to move it, then you can do set bit accumulator comma 7. So, now we are setting the 7th bit position. Now, this value which is in the accumulator, how to move to the PCON register comma accumulator. So, this way only we can set the baud rate of the 7th bit position, which is for S mode. If it is 1 means we can use it for the double the baud rate, which is for increasing the speed. So, with this I will complete my session. In today's session we have discussed about how the serial communication is performed and what are the supportings available in the 8051. So, we have discussed only the SPUF and PCON along with the RS-232 cable, how supporting for the serial communication. The SCON format and its corresponding modes will be discussed in the next lectures.